Hello everyone, I'm Andy Fisher. We're going to be discussing how to compile GridLAB-D with the Helix static C++ library, as well as going through some model examples and how to actually use or build a GridLAB-D model that acts as a Helix federate. So, the obvious prereq here is to, of course, build. You need to be able to build Helix. I assume in the previous tutorial discussions, we've discussed the prerequisites for building Helix. So all of those will be required. One special note about this is that I will be discussing the steps for building on Linux, specifically Linux systems, as those are the only ones that I have successfully tested GridLAB-D and Helix together. There's one additional setting we have to make when building Helix versus just your basic build. The CXX flags needs to have this -fpic set flag set and the standard C++14. GridLAB-D right now assumes that it works with under the assumption that Helix is built with the 0MQ core. Once the MPI core is fully available, I will be developing GridLAB-D to support support the MPI core as a setting. But right now everything is based off of a 0MQ core, so you will need to go through and make sure that 0MQ is installed on your system. So the current branch that contains the Helix code for GridLAB-D is in feature branch feature 1024. So on the GitHub repository, you can check out you can clone or check out GridLAB-D's from source code from there, and then of course you want to check out the feature 1024 branch. There you will need to, of course, go through and build all of the prerequisite standard prerequisite third-party software for GridLAB-D. These things include Xerxes, AutoMake, and libtool. But I won't be going through how to those. You can go to GridLAB-D's website, and they'll have links to show how to build those there. The other thing here, so when we get down, once you have everything checked out, we can, and of course you've built Helix, we can go through this. This is the standard build process for GridLAB-D on Linux systems. So this auto reconf IF. Then there's the configure step, and I apologize for this long, dirty line, but this is all the things that are necessary in order for building with Helix. If you don't care about, if you are installing to the system, you don't really need that prefix line. But this -- with Helix is is necessary because you need to be able to tell the GridLAB-D building scripts where Helix was installed. If it was installed to the system, then you would put /user /local or something like that. The enable silent rules is also optional. It kind of removes a bunch of warnings and things and makes the build script clean. The C flags, CXX flags, and LD flags must be set up this way. As if you notice, we're using zero optimization. That's due to an issue with the current version of GridLAB-D, but we're currently working on fixing that. The one thing to take note of that's different from building GridLAB-D regularly is this -std equals C++14 flag in the CXX flags line there. So that's the only thing that's that and the -- with helix directive are the only two things that are different about when building GridLAB-D with helix. And of course, there's the make and make install. But that's really that's all the build process there. Let's see here. Let's go to the next slide. Why isn't it not? Why are you not showing up? Come on. There we go. So when creating a GridLAB-D model that you want to use and you want to use the helix, or you want to enable helix federation within the model, these are the two. There's only one object that you need to add to the GridLAB-D model. That is the helix message object here, shown here. This is an example. You have the required properties are a name and a configure file. You don't necessarily have to parent this object to anything. You of course have to. This object is located in the connection module, so you will need to specify the module connection in your GLM. The name becomes the name of the helix federate for GridLAB-D's helix federate name uses that directive there. So you need to make sure that when in any of your federations that that name is unique. Otherwise, you'll run into non-unique issues with federates not knowing who to talk to. So one of the things required is to make sure that your federate is unique. So in the configure script here, it says JSON script. I will go to the next line here to just talk about that. So this configuration file is a JSON structured text file. It specifies subscriptions and publications for the federate. So right now, GridLAB-D implements the value federate. So, but I am currently working on implementing the combination federate so that it can support both physical value subscriptions and publications, as well as communication endpoints. So, but right now, all that's supported right now is value federate subscription and publication topics. But as you can see, the schema for the GridLAB-D configuration, helix configuration, requires 3 keys, basically: publications, subscriptions, and number of cores. So this is number of cores. It has to do with setting up your core init string, and for most cases, this is always just going to be 1, as in there's only 1 core per GridLAB-D federate, and that and for most of our use cases, that is the case. Sorry, someone is talking over me. The publication schema and subscription schema is fairly simple. You just use the object name followed, and then underneath the object name is the property that you wish to publish. So each property should have a subtopic associated with it. As in the example shown here, we have an object called network node, and we are publishing the distribution load property of it, and it is being published to the total load topic. So as you recall, the name that I showed in the previous slide gets prepended to this subtopic string. So the total topic would be the name, the GridLAB-D federate name / total load here in this case. Subscriptions follow the same property or same schema. You have the object name, and then the property name, and then the topic for which the property should be subscribing to. So in our example here, we have an object called network name who's with the positive sequence, and this is subscribing to this transmission sim / B2 voltage topic. So voltages coming in on this topic will get written to the positive sequence voltage property. And the same with this market 1 fixed price market sim. But that is the entire process of building GridLAB-D with Phoenix and setting up a GridLAB-D model to use the Helix library. I'd like to go ahead and show some build outputs so that people know what things look like when at each step of the game. So I'm going to go ahead and do that right now. So I mentioned before, this is the configure step of my Helix build. So I mentioned before that you needed to add the fpic and std equals C14 slide to the CMake CXX flags environment or variable here, and then of course you can just go through the regular build there. You should just be able to press C and generate and make and everything like that. But that's the only thing that's in addition to your standard build of Helix that you would need to make when building Helix. So here is the auto reconfig -lf build. It's fairly simple. This is if you don't see something like this, something may have gone wrong, and in which case you can always email me to see what went wrong. But here's the configure step. To know that the configure step worked, you just need to check to make sure that libxerxes says yes, and then the other ones are optional things there. So if they say yes or no, don't worry about those. But the only one that really needs to say yes is this libxerxes C one here. And then to make sure that you entered in all the correct paths for Helix and everything, if you scroll up in this, you'll see this checking for Helix line here. This must say yes. If it doesn't, that means that the script failed to find the Helix library and include files. So we would need to explore that per reason there. But that's, yeah, if this doesn't say yes, then the most likely case is the path included for where Helix was is not correct. And then here's a regular build process. So if you check, so if Helix, if it failed to find Helix, then when in building the connection module here, it would not build this Helix message .cpp file. So that you can always double check to make sure that everything is going correctly. But you should see this during the build, the make process. And then of course then there's just make install. Problems with make install usually arise from permission issues, so whether you have to sudo or not, depending on where you're installing it. Other potential issues. Because we're dynamically linking with Helix, all of the libraries that Helix uses, this includes the Boost libraries, the 0MQ library, as well as Helix itself. These all need to be, if they were not installed to your system at the system level versus a local level, then the path to the lib folder needs to be included in LD library path. That's the only case. If everything was installed at system level, then you don't need to worry about doing that. Otherwise, it would fail to find all of these libraries when trying to dynamically link with Helix. And that's how you build Helix or GridLAB-D with Helix.
Since this is only a half-hour meeting, we don't necessarily have time for questions. I have a 10-minute mini tutorial to give immediately following. So this is just a brief reminder that this is being recorded. If there is one burning question, I'll allow it. All right then. I am getting my presentation ready to present.
Jeff, while you're getting that ready,
Yes.
a quick question. This is Priya from PNL, by the way. So you don't have to provide broker addresses anymore in the config files?
Correct.
So, like, what if multiple people?
Well, that I actually haven't explored that issue yet to see if multiple people are running on the same computer.
Okay.
I think you can specify the addresses for brokers and things like that in the core init strings for your federates as well as for the broker, but it's not necessary.
Okay.
All right, this is embarrassing.